Hi, I'm Lars. Welcome back to the C# workshop. These next couple videos I'm going to cover reference types, and they're a little bit different than value types, so pay attention. Have you ever wondered where the term bug in a computer program came from? If you have, then stick around and let's get to it. Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. Although this video will concentrate mainly on reference types, we will be talking a little bit about value types too. I need to start talking a little bit about objects, not in depth, otherwise this video will become really long or it'll be broken into multiple parts. An object is what every type either directly or indirectly inherits from. As you can see in this diagram, objects are made up of either value types, which are broken down into like ints, bools, bytes, and stuff like that, or an object is a user-defined object, an array, or a string, and that side is primarily called reference types. Now, when I say car, people primarily know what I'm talking about. They think Chevy, Maserati, Toyota, whatever kind of car they drive or whatever kind of car they like, and that's what they think about. Now, if we take that up one level, you'll have automobile. And now this kind of starts getting a little more general at this point in time, because an automobile could be a car, it could be a truck, it could be a bus. Basically any four-wheeled vehicle or form of transport that goes across land. And now, if you step up even higher, eventually you get to a transport, which means you have a land transport, a water transport, an air transport, anything. I don't think anything goes higher than a transport. And when people in the programming world think of an object, they think of like a transport. It's very undefined. There's no specific information about that transport. All they know is it moves you from one location to another. That's it. An object, the only thing that they know about is that is how we get a class instantiated into memory. It's an instance of a class. And I'm going to stop that there because we still have another video on classes and objects coming up. Now I want to kind of go back to value types. And a value type, as you're seeing on the screen, we have memory and we have a variable stack. And I'm just loosely using the term variable stack. You can have an int, a short, a byte, whatever you need, whatever type of value type that we have, and they're tightly bound to that piece of memory. So when you say byte B, and that's equal to 100, literally you're writing that 100 exactly in the memory address for byte B. Same with the short, same with the int. So if we take short, the S, and we assign it to another short value type, S2, they will end up with the same value. Now, if I change S2 to 20,000 instead of 10,000, S2 will get changed to 20,000. And this is a desired result with the value type, because remember, S has its own memory address and S2 has its own memory address. So copying value types is very easy. To show this in C# is really simple. This will declare the S, and then we're going to assign the S by putting S is equal to 10,000. The underscore here is what's called a digit separator. It makes things easier to read while you're coding. And then we're just going to right line the S out. And if we go back and we look at the actual code that ran, you'll see it says 10,000. So nothing that you would think would be abnormal here. So now let's create another short, S2, and we're just going to assign it directly to S from the get-go. And I'm going to put a blank line in here. And we're going to print this out as this is S, that. And we're going to print this one out as this is S2, so it's easy to see. And we'll take this up here like that. Then we'll run it. And as you can see, S has 10,000 and S2 has 10,000 even after been assigned. Now, let's take these two. We're going to copy them down some, put a blank in here, and then we're going to say S2 is equal to 20,000. And that is exactly what we figured would happen, because S and S2 are literally two completely different memory addresses. So now that's how value types work. Let's move over to reference types. Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime. I think that was fairly easy to understand. For reference types, things are a little bit different, and it's because they use heap memory. And what that means is that the variable doesn't hold the data, it holds a reference to the address that holds the data. I'm going to demonstrate this by introducing everybody to arrays, which are reference types, and therefore they inherit from object directly. An array is a group of like type items. So say for our group, we want 5 integers, and we represent this visually like this. What you are seeing is the variable that is int array, and that's just a really bad name for a variable, but I just needed an integer array. It's going to hold the address in the variable stack of where the group of items is in memory. So the pointer that you're seeing there, the arrow, we call it a pointer. We're going to say int array points to the array of items. And they are an array. There's position 0, 1, 2, 3, and 4. And let's see how this works in code. This is the normal way that you do it. You would say int, and an array is 2 square brackets sitting together. Otherwise, if you did this, you would just have an integer. That's it. So this is an int array. The name is just like any other variable. It's going to have the name, which I'm using int array. And the new thing that you're seeing here is this new word is saying we need to bring this into memory, or you're instantiating it. Okay, that's the term when you're bringing a class into memory. It's called instantiation. And then you're going to tell it, well, I need an int array, but you need to define how big you want it. Now, arrays cannot grow and shrink. And I know a lot of things that you guys are reading on the internet will tell you that an array can grow and shrink. And it can, but you have to reconstruct it. Because when you're saying new int of 5 of integer, you're telling the computer or the application you need to allocate space for 5 integers. And that's what the new is doing. It's saying, hey, this piece of memory here that's 5 integers long is mine. And it's going to be attached to this variable down here called int array. All right. So this is exactly what you're doing. You are allocating memory at this point in time. Now, if we just take this and spit this out, and that's what we're going to use. We're going to use a for loop. And this is your int array. Again, it's an object. It is a class, and it does have methods and attributes and stuff to it. So if you come past this period here and you hit control and space, you can see all of the different attributes that we have and things that you might need, like first, that will give you the first item in the array. There's a last, it'll give you last item in the array, the length of the array, the max value of the array. There's all kinds of different things you can do with these arrays. Okay, we're going to use length because we want to print this out from 0 to the length of the array, which is 5. All right, so instead of just dumping out the value that's in the array, let's put a little bracketing here that makes it look a little cleaner. Well, let's execute this. And you will see that for the first position, we have a 0, position 1, 0, and all the way through. The reason is, if you remember back to the video on value types, I stated that an integer's default value is 0. This is setting these to 0 because we defined it as an integer array. So they're going to get dropped in there as a 0. The next thing that we want to talk about is how do we set the values for these arrays? And the way that we're going to do this here is the traditional way, again, because you need to know this kind of stuff. So we put this in as a 1. This is going to set the very first position in the array to 1. And then let's set the next position in the array, not the 10th, to a 2. And then let's set the last position of the array, which is 4. Because remember, 0 to 4, there's 0 base. to a 5. And let's run this. And you will see we have 1, 2, 0, 0, 5. It's like we set in the code. So let's try to make a copy of the array. And since we're going to print this out again, I'm going to put a break in here. And we're just going to say int array2 is equal to int array. Right? We're going to assign it to the array. So that's how we copied our value types. Now we're going to print out in 2 columns. We're going to print array1 in the left column and the array2 in the right column. And this needs to be array2 here. But since they're the same length, since they're a copy of them, we should just be able to use int array, the length of it. The only difference here is we're going to be pulling one value from array2 and one value from array1. So let's run this. And what you see is they are identical. And that's exactly what we expected. Okay, so that's how we, great copy of the array. Now what we're going to do is we're going to go in and we're going to edit array2. We're going to, in position 3, we're going to make it a 4. And we're going to print the exact same thing out again. So let's put a break in there like that. And that would not be what we would be expecting. All right, you can see very clearly here that they both changed. So now why did that happen? So let's go back to the slides and I'll show you why. Originally we had int array pointing to its array of 5 integer types in memory. And what we thought we were doing when we said int array2 is equal to int array1 is that we made our own copy, just like we did in the value types. But what we didn't realize is that int array2 got its own address, but realistically it was pointing to the same address of the original array types. And this is why they're called reference types. So when we said int array2 is equal or is assigned to int array, all we were saying is int array2 needs to reference the same memory location that int array is referencing. Now there's one more thing I need to show you in code. As we move through other videos, and specifically talking about methods, the reference types will become more prevalent at that point in time. There is something else that reference types have the ability to do, and that is being set to null. This is something a lot of developers forget about, and I don't know why, because 90% of the time they're dealing with user-defined objects, and every object can be set to null. So for instance, if we take int array and we set it to null, now what does this do for the array? If we throw this in like this, we'll end up with these little squigglies, and this will say int array may be null here. So if we hit F5 and we run this, you'll see we get a null reference exception. Int array was null. And the exception says object reference not set to an instance of an object. This is not primarily that int array is null. It's reason it's complaining is because you've got something that is null and you're trying to access something that you think is there. Now when you ran the compiler knew this was an array, so it lets you put this in here. And there's no issue with that. But this happens quite a bit in coding. There's 2 ways to go about this. One way is to use a null conditional, which is a question mark, and that will take care of your problem. All right. Now, your error went away, but you didn't get any output. So I'm not a big fan of putting this into a for loop. If you're going to use this, this is the proper way to do this, is to put an int array, a test to see is int array not equal to null. If it's not equal to null, then this here will work. So the little curly brace goes away. So you can do it this way. And I'll just show you that we still don't get any output. Or you can take this, and the traditional way is to do this and say where int array length is greater than 0. At least you're going to access something. You're not just going to dump out. And then throw in an else statement at the end that says something to the effect of int array is null or empty. Something to that effect. This I like better, and the reason is because of this. Hey, look at that. We got int array is null or empty. We actually got feedback from our code. So whether you're logging this someplace or throwing it back to the screen, that's fine. Now, what about this little question mark guy? The little question mark allows you to remove this. What this little question mark does is it looks at a nullable variable, which is an object or something that is a nullable type. And if it is null, it makes the conditional just return a false, just right off the bat. So if we run this, you'll see you'll get the same int array is null or empty. And that will shorten your code a little bit. In the long run, when it gets down to MIL, no, it's not. It's not going to shorten your code at all because all this stuff's just being added for you. Let me get rid of a bunch of this stuff. I'm just going to go up here to the top and I'll put a breakpoint right here. And the reason I was saying that's for nullable types is because you can use these on value types. It's like the bool, which is a value type, and it can only be true or false, right? There's no other options you put in there. You can't set these to null. You can't do anything else with them. If I come in and I put a question mark here, this just changes from a system boolean that I can now put a null in, and now it's a system nullable, where the t struct represents a value type that we can assign null. And you can use this on all value types. All right. So now when the question comes up about do value types use stacks or heap, now there's a blend there. Nobody really knows anymore because you're not allocating memory, and this is a nullable, so technically it has to have a pointer. So when we had int array and int array2 both pointing to the same memory location for the integer array, and then we set int array to null, you see that int array just got removed from the variable stack and the pointer got removed. The actual data did not get removed, and nor did int array2. It would be easy enough just to set int array2 equal to null, and that would remove it from the variable stack also, and it would remove the pointer from memory. On doing so, being that these are all just integers and they can't be set to null, garbage collection will come by and pick them up. Thanks for watching the video. Please like and subscribe to the channel. I really hope you enjoyed this video and understand how differently reference types and value types work in memory, which is very important because that is the tip of the iceberg for reference types. This is what developers like you and me create today in our object-oriented languages. In the next video, I will cover the most used reference type for programming. It's called a string. Where did the name bug come from for computer programming? Many people think back in 1947 there was a computer scientist named Grace Hopper who found a moth trapped in a Mark II Icon relay calculator at Harvard University. This moth was causing an electrical fault and was disrupting the system's operations. Hopper recorded this event in a computer logbook, noting as the first actual case of a bug being found. And a lot of people took that from there, that's where the word bug came from. But more than 60 years earlier, in 1876, Thomas Edison, during his lighting inventions, documented in one of his entries awful lot of bugs still, and 2 years later in 2 letters to Western Union President Theodore Puskas, he mentioned the word bug describing little faults or difficulties. In 1916, there was a reporter that was writing an article on Edison's team of researchers who were called the Insomnia Squad. So they worked a lot of late nights. Where he wrote this: like friends when they were fishing for a bug, that means that they are searching for something missing, quality, quantity, or a combination that will add something toward a perfect or whole. People used to write very eloquently in the 1800s. After this, the term bug was considered a malfunction of any type in any device. So now you know. You're always welcome here in the C# workshop. Have a nice day.